In this video, I'm going to be showing my new project. It's an HTTP server web framework I made in Rust, and my real website runs on it with like server-side rendering, and it's simple and it works. And the framework I'm going to be showing today is right here. So in cargo toml there is only two dependencies, HTTP parse and log. And in cargo lock, it's the same thing. And so I'm going to be writing an example, like, I don't know, program, a server, and I'm going to be using this framework, and I'm going to be explaining things as I go. I think maybe I'm not good at this. Anyways, let's start maybe with dependencies. So log is a thing that allows many things to log without knowing what the implementation would be, and so it's just an interface that's used throughout the the ecosystem. I'm not using anything actually from the ecosystem in my portfolio website. It's just the framework, and I also pull in log. And so I don't really care right now, but if I were in some future app that uses this framework to use a library that logs things, it would be cool if the framework supported logging. And also HTTP parse is parsing for requests. I'm using it only for requests, and it's just, well, because HTTP parsing is difficult maybe, and I don't really want to spend a whole time of my life writing an HTTP parsing library. And HTTP parse is like an industry standard in Rust right now. It's used everywhere, and so I use that. But everything else, like for time stamps, I use libc, and for signal handling also I use libc. Just a couple of small bindings and it's fine. Sorry. So let's try this. I'm gonna start writing, and then we'll see where it goes from there. So we need logging, and we are going to pull this from the framework. It provides the implementation. It doesn't provide any way to parse configs, so my portfolio website implements a parser on the application level. And so I'm going to hard code all the configs in the source code here in the example. And we're going to need a level filter from the log crate. And we are going to pass trace level filter, and that's going to be our application. Let's actually write something like test or something and try to run this program. There you go, we have a log with timestamp and level and a message. So the implementation actually works. And that's the first thing we're going to look at. Let's look at logging. So first of all, there is the static global logger, and it is being set with this function. and is being passed to the log crate to set that the logger inside of it, the global variable inside of it. And logging can only print to std error. There are thread IDs and request IDs supported, and we are going to actually look at this soon. So I hope to not spend 2 hours this time doing all of this, because it's not the first time I'm trying to record all of that. And so next thing we want to do is probably actually initialize a server to start talking about that part of the framework. We don't actually need anything. So right now it's just the framework setup. Here's the function in the framework. Setup sets up server with signal handling and then blocks. That's what it does. And the setup needs a server config and a request handler. And this function is basically all the API to the framework. There's only one request handler, and all the routing is, done on the application level. The framework doesn't do routing, it just parses HTTP, and it's quite low level. It provides utilities for constructing responses and for parsing target of the HTTP request. But we're going to look at that not now. So what we need is a server config. Let's do that. Let's import server config from the server module. Let config equal to that. And we're gonna need a handler also. But let's look at the config first. So server config. We need a host, port, workers, the amount of workers, and request buffer. So what it does, this server is synchronous, and it has a thread pool, and for each request it takes one thread from the beginning to the end of the request for each connection and request. So first, the connection is being established, and I'm going to show that in the code later. So we need host. This is going to be 127.0.0.1, and we need this as a string. Port, we're gonna do 8080 maybe. So the amount of workers, let's do 2 workers, and the request buffer, it's limited and is set at the beginning of the program. Why don't I have the internet? Okay, that's something. Also, anyways, because I don't want the resource exhaustion situation where there are so many requests that workers cannot handle them fast enough, and the channel that pushes jobs into workers, if it's a just normal channel, it can it can grow, and it can just take all the RAM, and it will be a denial of service attack. And so by utilizing sync channel instead of normal channel, we can set some limited size, some limited amount of jobs that can be buffered. And if, we cannot execute more than we can execute, we're gonna just not, service the requests, the incoming connections. It's still denial of service, but at least it's not going to crash the server. It's just going to quietly do the job, maybe slower than new jobs come in. And so then we need a handler. And the handler is going to be a function pointer. And let's create that function. So the handler, let's find it. It's actually here. Request handler. It's a function pointer where it accepts a request and it returns a response. That's the whole thing. And we need the types in our program. So we're going to need the request type. It's in the request module. And also the response type, which is in the response module. So it accepts the request and it returns a response. So let's look at what the response is. We can ignore the request for now. And we can create a response. So it's a kind of a builder pattern. And we're going to create the builder. And we're going to set the code on it, because without a code, it's not going to work. With code, we need codes also. No, it's inside of the response, right? So we need the codes, and we're going to do this. So this is going to be a minimal working setup. Let's try and run it. Something happened. So first of all, it bound to localhost 8080, and then it created a thread pool with 2 threads, and then it started listening for requests on that address, and we see a thread local log. So a thread from a thread pool acquired a lock for the jobs channel. It's waiting for an incoming request, for an incoming connection. We're not going to test this right now. Let's look at how it all works. So let's look at the setup function first. It just does some complicated things with it registers signals from the signal module, and it then starts the server in a background thread, and then it blocks on the signal signal message. It's an atomic boolean. And then when it unblocks on that message, well, if first of all, if the server just stops, the process exits. And if there is a message from outside, like Control-C or sigterm, it unblocks from this loop and it tries to gracefully shut down the server. There. I'm not going to explain this logic because it didn't work very well when I tried to do that last time. So let's just look at the start server function that doesn't do all of this decorating. It still needs the shutdown and acknowledgement channels. It's quite coupled to that logic. But I had to do it somehow. And so it binds just to the address we specified in the configuration. It creates our thread pool. What did I do? Let's look at this. So it just creates some threads. Create thread. It sets the thread local, variable. Thread local global variable to the thread ID. And then it just locks on the receiver mutex, and then it tries to get a function that it then needs to execute. This is going to be the handler. Thread pool is it's agnostic to that. It just requires some kind of function. It doesn't care, it just needs to not accept anything and not return anything. And that works well enough for a web server, because the listener doesn't really care about what threads are doing. Where was I? Start server. So it creates a thread pool with amount of workers and the request buffer size. And then it just blocks on the TCP listener on accept. This says that this function will block. So now then it does some also complicated logic with the signals and graceful shutdown. But in any case, when it successfully accepts a TCP stream, it just creates its stream handler and puts it into the thread pool. And if it can't do that, it just sleeps for 100 milliseconds to wait for workers to eat through the jobs that have been sitting there in the channel. And the stream handler is a very interesting function. It does the TCP and HTTP parsing. It also sets request IDs. We're going to cover that maybe. I don't know how this is going to go just yet. So this is the higher level logic. The request right now doesn't support bodies, and it only supports the head, which is parsed with HTTP parse. No, it's not called that. It's called HTTP parse. And then response is a fully custom module. It only supports a subset of HTTP codes, and all of them support body. And so it always returns content length, and also it does connection close, because this TCP, HTTP server doesn't support using one TCP connection for many requests, because that's going to take up a whole thread, and I can't afford that. So it just drops connection so it can keep processing new requests. That's a limitation, but it doesn't really matter, because most of the time such servers are behind reverse proxies, and reverse proxies just handle that thing, and it's not expensive to set up a connection on the local host. And so let's look at the response builder. So I'm using a vec here because I don't really care about allocations right now. And so we need to set code, and we can set body and optional headers, and also those are strings, because I don't really need by generic. That's all I needed. That's all I'm gonna say. And so body is just a trait object that implements read, so it needs to return some bytes on prompts. And because it's HTTP, we want to know its size in bytes in advance. HTTP supports unknown body sizes through what's it called, transfer encoding chunked, but I don't want to support that, at least now. And now we're going. This is just normal builder stuff. And now write head is an interesting thing. So first, it tries to get the code that we have to set while building, and if not, it just errors out because we didn't provide any code. And there are only two errors that could possibly occur, and those are if we as a user of this interface, of this builder interface, did something wrong. And so the only supported codes are then turned into reasons, the static strs, and then byte by byte, str by str, we build the response. So it's just normal stuff. So we see if there is body, we set content length to its length, and if there is no body, we set its content length to 0, and we always set connection to close. And then we do the normal HTTP head and sequence of bytes 2 times crlf. And then build just gets the buffer for the head, and then it returns optional body reader, so it knows the size, and it's a trait object with read trait. And the bodies that can be set are here. So it can be either a string body, and it's just the length of it in bytes. To use the string, we need to first turn it into bytes, and then use a cursor to have the read trait on it. It can also be just a vector, it's not vector, it's vec of bytes in memory. We could not just use that function and call into bytes on every string that we pass, but this is just more convenient for HTTP responses and stuff. And it also can be a file. This is very cool, and that's exactly why body is such a generic thing. That's why it's trait object of read, because that's just, it only needs implementing one kind of logic. You read into a buffer, and then you send from the buffer to the client. And it can be anything. It can be a string, it can be a byte vec, or it can be a file, or it can be another connection. It can be anything else, and so that's really convenient. It could be an enum, and it could be optimized, but that will complicate the server logic. And so now that we know how to construct a response, Let's look again at what we're doing. We're just constructing a response and we giving it code OK. So now we know that this will construct a response. It will have content length of 0 and connection close. And this is going to be the whole thing. And let's actually go to this address in the browser and see what's happening. We get just an empty white screen, and in the logs we see that there were two requests. One is 652 bytes and another is 578 bytes. We're going to discover what those are. Let's first log that there is a new request. It's a macro invocation, so we need to give it an exclamation mark. So as you can see, when I pressed Ctrl+C, it didn't just shut down. It says that it received shutdown signal, and then it gracefully stops all the threads and all the work. And so let's start this again with the request logger, and this is going to print request IDs now. Let's go to this address again, and we see that there are two requests. Each request has a sequential just number and a timestamp. So they're unique and also easy to understand their relationship to each other. They have timestamp in addition to a sequential number because, well, you can see if the server restarts, sequential number also does. And we want like unique IDs. That's why I added a timestamp. And so now we probably want more information about the request, so we can construct a informative response and actually useful, something useful. And so for that we need to look at the request. First thing that we want is a method. It's in the head, because that is the HTTParse request, and the method is an option. So we want that to exist. And let's create actually bad request handler that just creates a response that's always the same. So it's going to be a response with code bad request. It's going to have the header content type, text, HTML. I think that's what it should be. And it will have a string body that's gonna be 400 bad request. So it's going to be else return bad request. So now we have a method. For some reason method is not a method, it's just a field. And so now we have a method. New request, method is method, let's do the response thing, and we're going to return it after we process the request, and we're going to also write the code of the response. Let's actually just do that. So it's going to write the code or 0, because I don't want to think right now. Now, if we cargo run, and we do this again, in the logs we see that it was a request method get, and we return code 200 twice. That's what we did. But we don't know what it requested. So we need a path, a target. So we want the target. It's called path in HTTParse, but it's actually not. And so we want the parser, and it exists in request target module. That's also a custom parser. It implements the RFC, kind of, well, poorly, but it works. So target parse target. Or we also want to do the bad request thing. So the target now is an object, and that has the full original target. It extracts scheme, authority, path, and query. And it can also error. There are quite a few errors that can occur, because HTTParse doesn't really check anything. It doesn't even check if it's ASCII, let alone checks it for if it's correct. So I wrote some tests, some happy paths, and also some error conditions. So it should work, and it works on my website. And so now we want to log the target. Let's log its path. Actually, let's do the path thing. Let's extract it or do the bad request thing. And now we have a path that we can just use. Let's log it in the request log and the response log. Start the server again and do the request again. Now we can see that the first request we're getting is just the home page. We want the home page. But the second one, our browser wants a fav icon, and we also return 200, although we don't have that. And so now we want to do some routing probably. And that's where the application logic comes in. What I do is I match on method and path, and if it is like get and it's the home page, then we want to do the response thing where it does it to 200. But if it's anything else, let's create a response that does a not found So let's see. We create the server now. It has some simple routing, and we do a refresh of the page. Now we see in the logs that for homepage we return 200, but for fav icon we return 404. And if we look at the network logs in the browser, we refresh the page, Control-Shift-R, so it uncaches everything. For the home page, it does connection close and content length 0, just as I said. And for fav icon, it also does the same thing, but it's now 404 not found for the favicon.ico. And also it does peculiar things, like it wants well-known app-specific chrome devtools.json, and that also results in 404. Now let's actually do some HTML, some hello world. Let's do a heading, so it's going to be h1 tag, and we're going to do hello world. So now let's start the server again and refresh the page. We can see that we have our tag hello world. It's not a well-formed HTML document because it doesn't have the normal structure with HTML, the head and the body, but browsers are smart nowadays and they can render even incorrect HTML. And so if we try to go to something else, some other path, like FFFF, it returns HTTP error 404. It says it's failed, and it doesn't even, say anything, it doesn't show anything. And so if we want to not just send code, but we also want something to show on the screen, we can send an HTML. And now if we do something, I forgot to recompile. So if we refresh the page now, we can see that this is 404 not found, and if we go back to the home page, it actually routes correctly and it returns hello world. So yeah, this is the server. It doesn't support request bodies right now. It's not difficult to add, I just didn't need to yet. But this is how I made my whole website. It doesn't even have any JavaScript, and everything is being rendered. I don't have the internet. That's what why don't I have the internet? I don't get it. So it's server-side rendering, and it fully renders the HTML in code like this. Like I do some string manipulations, I glue things together, but it's fully constructed in Rust without any frameworks, just pure string manipulations. And it has no JavaScript, and it's just that. What I showed here, the whole website is like that. So I can just it's portfolio website. Let's cargo run, and it's on 127. It's not 8080, it's 8000. So yeah, this is fully server-side rendered. I'm not going to show the logic right now. That's for another video. But that was the framework. I wanted to show how the TCP stuff works, but I'm not going to do it right now. I think I'm gonna do it in the next video. So this was just a demonstration of the framework and how it works.